We are down to the final section in Chapter 3. This is Section 3.6 in Reedy's Geometry. Welcome again. We're going to do an application of some of the geometry we've been working on in the coordinate plane so far. An application is just how it is actually used. And one of the kinds of problems that you see a lot, not only in like navigation, planes that have to make a stopover and finding the minimum distance for a stopover, but also all kinds of what they call optimization problems. And optimization is just a problem where you're trying to find the best way to do something. The minimum cost, the shortest distance, sometimes the longest distance that you can get out of something. It depends on the real life situation. But this is something that comes up a lot, and this is a minimum distance problem. There's no note card for this, but there are going to be 2 steps and you'll just have to know them. I'm going to work number 10. And all of the other problems on the assignment for Section 3.6, the worksheet, are very much like number 10. You do the same 2 steps every time. So here we go. Number 10 says, you want to find the shortest path from point A, hitting the x-axis, and then going to point B, so that the distance from A to the x-axis plus the distance from x-axis to B is the shortest, as short as possible. In other words, here's what I'm talking about. Somewhere on the x-axis here is a point. Let's say it's the origin, just for the sake of argument. Then the distance from A to that, plus the distance from the origin to B, when I add those 2, it's the shortest. Now, if I move the point this way, that shortens the distance from A to the x-axis, but it lengthens the distance from B. Is that sum, the sum of those 2 distances, shorter here, or when the point moves to there, or when it moves closer to B? Then the distance from B to the x-axis is shorter, but A to that point is longer. So how do you get the minimum distance? Here's how you do it, and this is 2 steps. If you're trying to find the minimum distance to the x-axis from one point to another point, start with your second point. Step 1, reflect it across the x-axis. So I'm going to take B and reflect it across the x-axis. And where will that be? Well, that'll be right down here. That looks like 4, a perpendicular 4 distance. So I go down 4. Here's what I call B prime. That's B reflected across the x-axis. And now what I'm going to do is draw a segment from A to B. You need to do this with graph paper and with a straight edge or a ruler to draw your segment straight and make sure where it goes through the x-axis. So now I'm going to connect A and B prime. All right, sort of like this. There's a segment that connects A and B prime. And the question is, I reflect that across. Now I draw that segment. That's the second step. Now, where does that segment cross the x-axis? It appears right at 0, 0. So my answer here, the point on the x-axis that minimizes this distance from A to the x-axis and then from the x-axis to B is 0, 0, the origin. And that is my answer. Reflect the second point across the x-axis. Draw the segment from the first to the second and see where it crosses the x-axis. Try some of these minimum distance problems.